Hi everyone, welcome to my channel. Okay, so some of you may be seeing this video for first time and some of you may be seeing this video for second time. In the previous video which I uploaded, there was issues with that video. If you hear that video from mobile, the volume was very low. So that's the reason I'm creating this video again. Okay, so in today's lesson, we are going to learn what is linear regression. Linear regression is the algorithm which is used for regression. So what are the regression problems? Let us first understand is in regression problem, we try to predict uh, you know a continuous variable. So let's take an example. So suppose we are predicting prices of a house. Now price of a house is not a discrete number. It cannot be a one or two, or it can be a yes or no kind of thing. It has to be a number between one and some say $1 million. So uh, so you have to write a model which uh, predicts values between 1 and say million. Like it can be it's a continuous number that it is predicting. So example is predicting house prices from lot of features. So when I say features, I mean to say factors. So house of a price depends on a lot of factors. Uh, those factors are area of the house, number of bedrooms in the house, number of bathrooms in the house, amenities that you're getting in that house, and area of that house, and locality it is part of. So all those things contribute to the cost of the house, price of the house. So all these factors are called explanatory variables, and we are going to denote them with X. So price of house is the variable that we are trying to predict. We are trying to predict the price of house, right? So that is called dependent variable and it is denoted as Y. I hope this basic thing is clear. Now we will start understanding that what is linear regression. First we'll start from a single variable so that it is easier for everyone who is new to machine learning and linear regression. Also, I know few of you folks might have already read linear regression or worked on it earlier in your career, but there could be a lot of folks who maybe for whom it will be very new. So I'm going to start with a single variable and explain you the intuition behind linear regression. Okay, for this we are going to take predicting pizza price example. So let us start with it. Let me close this one. Okay, suppose we have information about size of pizza. So this is our variable, say 3, 4, 7, say 8, say 10, 13, 15. Okay, so we have pizzas of this size and the relevant cost is $4 and say $6, $7, $9, $11, $15, $17. So we have a variable which is our output variable where we have cost of pizza with us. Cool. So now let us try to first understand the data. Normally it is very good if if you visualize your data first. Okay, import matplot. So matplotlib is a library which we are going to use for plotting our data. So I'm going to just import it. Now to see, okay, give me 1 minute. Now to see our uh, images within this notebook, we have to call this magic function, inline magic function from Matplotlib. Let's call it. Okay, star means here that this command is still running. So, uh, our server is still running this command, and after this command is complete, this command will be automatically started. So let us wait for a few seconds. Okay, this is done. Cool. So now let us print our data scatter x comma y. Cool. This is a plot of our data. You can see that there is a linear relationship here. So let me plot x-axis and y-axis. I always forget about this thing. On x-axis, we have pizza size. On y-axis, we have pizza cost. So you can see that there is a linear relationship between pizza cost and pizza size variable. Oh, I'm sorry. Pizza size and pizza cost variable. So what do I mean from linear relationship? I mean from linear relationship that as the cost of pizza increases, size of pizza increases, the cost of pizza also increases. This means uh, uh, so you can see that this is roughly a line. The relationship can be represented by a line roughly, not exactly a line. You can't put this thing exactly into a line, but roughly a line. So that's what it means from linear relationship, that if you generalize the data is roughly, it can be fit into a line. That's what we mean from a linear relationship. So linear regression is used when we have linear relationship between our uh, features and our output variable. Okay, so a few more things I want to explain here. So our relationship, suppose this is our data. So our relationship between our data can be like this, where it is, so as the value on the x-axis increases, value on the y-axis also increases. So this is y-axis. So this is called positive relationship. Now, there can be situations where the data may look like this. So here, as the value on the x-axis is increasing, value on the y-axis is decreasing. So this is called negative relationship. So just for people who are interested. Okay, so let me create a new one. Okay, let's draw some stuff and understand linear regression. Suppose this is our data, and this line represents our model. This line represents our model. Pardon me for the drawing. Okay, so uh, so our predictions are going to be on this line, and these dots represent the actual data that we have. So imagine this. If our pizza is of size 3, then actual data says that the value should be 4, right? But here the model says that value should be, actual data says the value should be 3. Sorry for that. And here the model says that the value should be 4. So the so what we understand here is the values predicted by model can be different from the actual values. So here the difference between this and this point is called error. So I will denote it by E. So this is a error. So like that, there can be some variation in all the predictions from the actual ones, right? All those things are error. So what we do here is that we try to minimize the error. So now you can see that there are a lot of dots here, right? Lot of input data we have. So there could be this line, there could be this line, there could be this line. How do we know that which is the line which best represents our data? Which is best fitting our data? So the answer is that the line which has the minimum error, minimum total average error. So I am just putting it into simple words, but there is a proper formula, like you do uh, average of the squares of a mean square error. You find out that. So just for understanding, just ignore that part. So you can think of it as that the average error should be minimum. So that's the funda. So line which has the average minimum error is our best fit model. That's our best model. That's the best line that is representing our training data. So that we are going to use as our model. So this is all about linear regression. So a few more things. Uh, how do we represent a line? So you might have seen that in your college that we represent line by you know this formula. So here y is the output variable and x is the feature. So x is the pizza size and y is the output variable pizza cost, which we are interested to predict. So if I draw something here and if this is my model and there are a lot of points around it, so this is my best model, then this interceptor is b. So b is the point where our line is cutting y-axis, and the slope of this line is m. So slope of the line is representing m. So slope represents that if I change value of x on the x-axis, how much it is impacting the value on the y-axis. So that's why it is called slope. So if it is impacting more, the slope will be more. If it is impacting less, the slope will be less. So that's the formula of our line. So this is the formula if we are using single variable linear regression. Now there can be multiple factors, right? There can be multiple factors which may be impacting our model. So let us first understand it. What could be those factors? So that can be size of the pizza. Let's call it x1. That can be toppings. Let's call it x2, and that can be demand of the pizza. More is the demand, more costly is that pizza. Let's call it x3, and that last thing can be amount of cheese that you put on your pizza, right? Let's call it x4. So in this scenario, our model cannot be represented into two dimensions. It will be a multi-dimensional model. So each feature x1, x2, x3 becomes a dimension in this scenario. So and the earlier we had a line which was representing our model, our data, right? Now we will have a hyperplane which will be representing our uh, data. So you can think of hyperplane as a multi-dimensional line. It's uh, it will be a multi-dimensional line which will be best fitting our data. So we will be representing our model like this. Okay, let me write it down like this. So y is equal to b plus x1 w1, x2 w2, x3 w3, and x4 w4. So X1, X2, X3, and X4 are our features, and W1, W2, W3, W4 are our uh, slopes in that specific dimension. So X1 is one dimension, X2 is other dimension. So every feature becomes a dimension. So for that feature, what is the slope? How much that feature is impacting Y? You can think of it as this. So this you can think of as a multi a multi variable linear regression. So it is very simple. So I hope you have got the intuition of linear regression. In next video of linear regression, we'll go a bit more into depth, and we'll take a scenario and get deeper into the data. Thank you.